Hello, everyone. In this lecture, we are going to talk about working with strings and string manipulations. So strings, in general, you can consider them as an array of characters, okay? So you might say, well, str equals hello world. So when you define them, you can define them in single quotations and type whatever you want. The color of them is purple. And you can see that you get this str. Now, if you say whose, it is really considered an array of characters when there are 11 characters in it. So 5 for hello, 5 for world, and 1 the white space. And you can deal with them the same way that you deal with arrays, right? So for example, if you want to access this letter H, you say str number 1. If you want to access letter D, you say str number 11, or you can use the keyword end that you had in the past. Okay, so very similar. It's just an array of characters. That's what it is. Now, there is a new class in MATLAB since several years ago that if you define something using double quotation marks, okay, and maybe I call this str number 2. Now I'm using double quotation marks and define this str number 2. Now, if I go and look at whose, you see str number 2 is not of type character. It is a class of its own called strings, actually. So when you use double quotations, now it's not 11 elements, 11 characters. It's just one single object. It is of type strings, and it takes a lot more space than when you define it as a bunch of characters with single quotation marks. Last time it was 22 characters, 22 bytes, 2 bytes per character. Now one single string takes about 166 bytes. So defining something as strings with double quotation mark is taking a lot more space. Plus, if you go and say str number 2, number 1, it's the whole thing. Okay, it is just the whole thing. It's not like you cannot access that single letter H or E or L by simply typing str number 1 or 2 or something. But if I define another string, string number 3, and let's say I add one more thing, string number 3, correct? Which is again one string just like string number 2. Now, can I say str number 2 plus str number 3? Yes. You see, it simply concatenated them. Now, if I do something similar, but using single quotation marks, and call it maybe string number 0. So now string number 0 is just a bunch of characters, just like string that you defined originally. Now, can I add string number 0 and this original string together the same way that I added 2 and 3? No. Why? Because there are two different lengths. One of them is 13 characters, the other one is 11 characters. You cannot simply add them. And addition has a different meaning. So this class of strings that is recently added to MATLAB the last few years, it has its own functions, and it is different than an array of characters. What I'm going to mostly today talk about is this array of characters, because you can access them, every single bit of information in them, and do whatever you want, okay? So if I want to concatenate like this, I don't need to use plus. I can simply use concatenation. You might say, well, can you do something like this? Sure. So I can do the same thing that I used to do. I can do here with plus, I can do here with simple concatenation. So I would prefer all the time to work with these characters, array of characters, than the new class strings, because they take a lot less space and they are more accessible than this class string. So I would define everything with single quotation marks, not double quotation marks. So that's the first thing I wanted to clarify for you. Now, if you want to know whether this str is of class character, you can just simply use isChar. Is str0 a char? Yes. What about str2? No. So you see, that's another thing I told you. Characters and strings are two different classes. So string number 2, which was double quotation hello world, is not char. Okay. So that's another way that I wanted to talk about it. One other thing I want to talk about is conversion from characters to numbers. Okay, what do I mean by that? Well, if I have letter A, correct? That's a character. And if I say, what is the double format of this? So I'm doing the typecasting, right? I'm converting the character into double format. It says 97. Well, that is quite interesting. How about if I add number 5 to this small letter A? Can I add a number to a character? It should give me an error, right? Well, guess what? It doesn't. Although I expected an error when I add a number to a character, it doesn't. Why? Because when I'm doing this, it does this top operation first. It does typecasting. It converts letter A to its equivalent number, 97, and then add 5 to it and make it 102. And now if I want to know what 102 correspond to, which letter, I can just say what? Say char of this answer. Convert this answer, which is 102, convert it to character, see what you get, F. So it says if you add 5 to A, you will get F. And guess what? A, B, C, D, E, and F. The distance between A and F is 5 characters. Okay, so you see it makes sense, this typecasting, converting a number to a character, converting a character into a number. The only thing is, where does this number come really from? 97 for A, 102 for F. Where does it come from? That comes from what we call the ASCII table. So ASCII table is a table like this, which is used in most of the standards for programming. And all of the signs, letters, numbers, everything that you can type on the keyboard, they have a corresponding decimal number for the purpose of programming. Okay, so when you, for example, click on the ampersand or the pound sign or percentage sign, computer does not recognize percentage sign. Computer recognizes number 37. So when it sees number 37, it knows that the percentage sign is pushed. Or when you say, for example, let's say semicolon, to computer, it means number 59. So this ASCII conversion table is very important in order for computers to understand what you are typing. And these conversions I showed you are all based on this ASCII table. Good? So let's move forward. What else we need to know? One of the things I mentioned, and I want to emphasize one more time, is concatenation. If we want to combine the strings together, how can we do it? I just showed you here that here I have str and str0. They are two different lengths, correct? You see one of them is 11, the other one is 13 characters. Can I concatenate them like this horizontally? Sure, no problem. Okay? By the way, there is a problem here, and that problem is when you concatenate, there is no gap between them. There is no white space. Okay, there is no white space here. So if I want to combine these two and maybe add a space between word and I, well, if I do it simply like this, it doesn't work. There is a command in MATLAB called strcat, which is a string concatenation. And instead of doing this combination with brackets, you can simply pass the items you want to combine to it, separate them by comma, but that gives you the same answer. It does not insert a white space between them. Okay? And the good thing with this is, well, you can add more if you want. You can add several inputs, that's fine. But you might say, well, can I add a white space like this? So I add a string where that string is a white space. Can I add that in between str and str0 to add this white space I need here? And guess what? You can't. What about this? Could I do something like that here? Yes. Interesting, right? So the command strcat, between the characters, if there is a white space, it ignores it. But if you simply concatenate them by simple brackets, you can get it to work like that. So you might say, is there really no way I can use this command strcat to add that white space between them? There is. The only difference is once you do this, this white space should be inserted as a cell like this. If you do it like that, then yes, you can get what? You can get the space that you want. The bad thing is it converts the whole thing into cell because one of them was cell. So if you really do not want to convert it to cell, just want to insert that white space, then I recommend this method. Okay, so this is about horizontal concatenation. Now, there is vertical concatenation also, strvcat. So you might say, well, can I do str vertical concatenation of a string and string 0? And it does, but you see something interesting here. Two white spaces are added to the end of str to match it with str0 below each other. Why? Because in order for two strings to be concatenated vertically, you have to have both of them be the same number of characters. This one is 13, that one is 11, so you need two extra white spaces that MATLAB forcibly added here for you to make them the same length. You might say, could I just use the concatenation like this? And the answer is no. Since they are arrays of characters, you cannot put an array of length 11 and an array of length 13 below each other. So this way of concatenation is not going to work. The strvcat makes them equal by adding white spaces to the shorter one to make it the same size as the longer one. And you might say, well, what if I really want to combine them together vertically without adding these two white spaces? I mentioned that in the video lecture for cell arrays, and the solution for it is to go with cells. So you have to do it like this. Treat them like cells. Then you can combine them without adding white spaces. Again, the thing is, it converts the whole thing into cells. Okay, but that's also a possibility. So this is horizontal and vertical concatenation. The other thing you want to do is to compare strings together, right? You want to compare two strings, see if they are equal or not. For example, let's say I have string number 1 and string 0. Can I do something like this? Are these two equal? Well, it's not going to like it. In order to compare two strings, they have to be, again, the same size. If they're different sizes, there is no comparison. So now, for the sake of learning, I change str regular str, or maybe I call it str1, that's fine. Let's just make sure this is also 13 characters. So it was hello world, right? I add 2 exclamation marks. So now str1 is also what? 13 characters like str0. Now if I say whether these two are equal or not, these two of course, now you don't get an error. Actually, you get what we call a logical array. So what does it do? It goes and compares what? Compares character to character. In any index, any location where both characters of the 2 variables are the same, you get a 1. Anywhere else, you get a 0. So it means the 3rd character of str0 and str1 are the same, and they are. If you put them right under each other, okay, you clearly see that the 3rd character is L, but anywhere else they are not the same. Okay, and so that's comparing what? String to string. If you use double equal sign, it does not tell you whether the whole thing of this and the whole thing of that are equal. It is telling you letter by letter whether they are equal or not. What if I really want to know whether this string and this string are identical? There are 2 ways. One, either you set them equal like this and look at the logical array. If all of the numbers in this logical array are 1, then it means they are equal. If one of them is even 0, that means what? Yes, they are not equal. The other way, that is this MATLAB built-in function that does the same thing, is the command strcompare, CMP. And you just pass to it the 2 strings, and it gives you a single number, 1 or 0, whether they are equal or not. So if you want to compare the whole thing to whole thing, I recommend use strcmp, compare. Now, sometimes 2 things are equal, but some of the letters are lower and uppercase. And you know, MATLAB does care about lower and uppercase. So in MATLAB, if you use small letters for MATLAB in str number 0, that's not the same as the original, right? So let me show you here. So this str number 1, I add something like 5. And maybe I just make hello and word the first 2 letters what? Small letters. Now if I say is 1 and 5 the same thing, are they the same thing? It says no, of course not. Although they look very what? Similar, but they are not the same. There are upper and lower cases. But if you say, well, how about if we ignore the lower and upper case? Ignore, strcompare, ignore casing. Ignore the sensitivity to case. How about that? Now it says, yes, they are the same. Okay, so you can compare 2 strings without caring about upper or lower case. That's strcompare, ignore. There is another one. You might not want to compare the entire string to entire string. You are only interested in comparing the first n letters of the 2, not all of it. Can you still compare? Yes, the command to go about is strncompare, the first n letters. So you say, hey, is str1 and str5, their first 4 letters are the same? And it says no. Now it says, what if you ignore the casing? How about that? Then it says yes. Okay, so a portion of 2 strings, whether they are upper or lower case or you don't care about it, you have all of these commands that you can use. Okay. A few other things about the strings. So strings have tons of functions, but I want to show you the important ones. One is if we want to know which parts of the string are numbers, which parts in the string are letters, which parts are white spaces, which parts are uppercase, which parts lowercase, which parts are punctuation marks, and so on. So basically categorize the characters in a string. How can we find out about that? I'll tell you. By the way, there are two commands that I want to tell you right now, and they are important, and they are upper and lower. If you do upper and apply it to any string, it converts all of its character to uppercase. All of them that are alpha, right, A to Z, it converts all of them to what? Uppercase. You see here? By the way, if you remember, str2 was what? str2 was string, it wasn't character, correct? This is str2. But the command upper acts on the strings too, not just array of characters. Okay, so it doesn't matter. So here, you see I applied it to string 1, I can apply it to string 0. It makes everything upper, and I can do a similar thing with the lower. There is the command lower. It turns everything into lowercase. So keep these two important commands in mind. Now let's go and focus on categorizing. So str number 1 is this, right? Now I want to change it a little bit and say str number 1 is, let me add a little bit extra stuff to it, or maybe I add something new. String number 6 is I like MATLAB 2021, and there we go. So now I have numbers, uppercase, lowercase, letters, special character, and white punctuations, and or maybe I add a dot and white space, right? So now I want to know which letters in string number 6 are numbers. So the command to use, which covers lots of ranges, is called isstrprop. Is that part of the string has special property. And then say str number 6. What do I want? I want it to be digit. Which part in string number 6, which characters are digits? And then it tells me the number 15, 16, 17, and 18, which if you clearly see, these are these numbers. The last one is not. And before 15 is not. Okay, only these guys are 1 and they are digits. So how about alpha? Which one of them are A to Z? It says, well, most of them, except for a white space here, a white space there, a white space there, and then all of these numbers and the punctuation mark. You see? These are those numbers and dot, and these are the white spaces. So we can say alpha, we can say digit. What else? Which one of them are upper? It says I is and MATLAB. Which one of them are lower? It tells you, right? This is like, and that's it. Which one of them is W space, white space? It's the second one and this number 7. So W space means white space. And which one of them is punctuation? Pint. Only the last one, the dot. So we have pint, W space, upper, lower, alpha, digit, and there is even one called alpha numeric, which can include both letters and numbers. So if you want to know more about this isstrprop, you can look it up, but this is really to categorize different characters in a string. Very powerful command. Okay, what else? let's talk about some more important things. Yeah, there are too many things in strings when you are trying to work with them. One of them is getting rid of extra white spaces. So I told you about how to add a white space, but now what if you really want to get rid of some extra white spaces you have in the word? Can you do that? Yes, there are two commands in MATLAB called strtrim and deblank. Okay, what are they? Let me show you. So here, I create this string number 7, and I add a leading white space, and I add a trailing white space, correct? Two of them. There's one at the beginning, one at the end. Then one of the commands, as I told you, is called strtrim. If I pass this str number 7 to it, what do you think would happen? Look at that. Both leading and trailing white spaces are gone. Only the middle ones are remaining. But deblank, if I use deblank, then only the one at the end, the trailing one, is gone, the leading one still remaining. Okay, so this is about removing white spaces, deblank and strtrim. Now, you might say, well, can I delete this first one by the way that I did elimination in other vectors, setting them equal to empty bracket? Can I say str number 7, entry number 1 equal to empty bracket? Yes. Can I do the last one also by end? Sure. Okay, so if you want, you can simply set them equal to empty bracket because these are simply arrays of characters. But there are commands too, like deblank and strtrim. Okay. One other thing is parsing a sentence into individual words when those words are separated by white space, by comma, or any other thing that we call delimiter. Let's say I have this str number 7, and I want to break this down into 4 words: I, like, MATLAB, and 2021. How can I parse it, split it into its sentence, its words, and get rid of the white spaces? So as long as the words are separated by white space, I should be able to recognize them and use them. So the way to go about it, I can use a for loop and go through them. Anytime I reach a white space, then I skip it and go to the next one. But there is the built-in command that does the same thing for you, and the command is called strtoken, T-O-K. You pass to it this string that you want, and what does this one do for you? It gives you 2 outputs. One of them is a token, the other one is a remainder. Look at that. Token is the first word. Remainder is the rest of it. So the first word is I can save it. Then I apply this command one more time, but instead of the original sentence, I applied it to what? To the remainder. Now token becomes what? Like. Again, I save it. I get this remainder. I do it one more time. Now I get MATLAB out of it, and I do it one more time, and I get what? Nothing, because the last time I did it, the token was here, 2021. That's it. And remainder is what's now? Empty. So if you do this operation, because you see I did it 4 or 5 times, I keep doing this, applying token remainder, token remainder, token remainder, until my remainder becomes what? Empty. And then I can get you what? All of the 4 words in it. Okay? So by a simple loop, since I don't know how many tokens are in the sentence, I use a while loop, and I'll do it right now for you. And I can find out exactly how many words are in the sentence. So let's do that as a practice. So let's say they said, I give you some string like that. You tell me how many words are in it. And then also give me all of those words or display them on the monitor. So let's say this is the input, str7. Good? Now what? CLC and clear and close all. So this is what I do. I say first, apply the token command to the original one time. Good. And if you want, if there are spaces in this str number 7, you might use deblank and get rid of them. Let's get rid of the leading and trailing while the spaces, get rid of them. And then apply the token. I get a token, I get a remainder. Now, if you want, I can display the remainder, the token right now. So I say display the token, correct? And there is one other thing. I can make it fancier if you want. I can add a counter, set it equal to 1 once I apply the first token command. And then maybe I say display the number to str of counter word is, and then token. So what I'm doing, I'm combining a bunch of strings, a bunch of character arrays here, concatenate them and display them. So this one says the word number 1, right? And the thing is, you have to add st here. So I say, maybe I do this. Word 1 is, and then token. Good. Now what? So I show the first word, and counter keeps track of how many words I have. Then I do a while loop and say while not is empty of remainder. As long as the remainder is not empty, then what? Apply this token command again, but on the remainder, not on the what? On the original string. Every time you apply to it, add 1 to the counter and show the word. And then end. That's it. So now let's do that. So I call it string demo number 1. And look. Word 1 is I, word 2 is like, word 3 is MATLAB, word 4 is 2021. Okay? Yes? So you clearly see that it is working just fine. Now, maybe I add this white space here, and maybe this one here, and this one. Do you think it works if I add these spaces? Do you think all of these missing spaces are going to go away? Yes, of course. Yeah, so you see, clearly, it tells me exactly how many words I have. And I can parse my sentence. So that's str token. What else? There are two more important powerful commands, strfind and strreplace, and these are used for find and replace, just like you do in Microsoft Word. So what you need to do here is you pass one string or a bunch of characters, and it tries to find the first location or locations where this sample or template is found in the major string. So let's say here, I have this I like MATLAB 2021. Then you say this. You say strfind in string number 7 wherever you see something like MATLAB. Find the word MATLAB in this string number 7 and show the result to me. And it does that, and it says the result is 9. What does 9 mean? Means the 9 character of the major guy is where word MATLAB is started. So look, 1, 2, 3, 4, 5, 6, 7, 8, and the start of MATLAB is what? Character number 9. Good? This is called find. Now you might say, well, don't find, replace for me, not just find, replace. strreplace of what? In string number 7, wherever you see MATLAB, replace it with whatever you want. Maybe I hear so many people say MATLAB. Whenever you see MATLAB like that, you say MATLAB like that and do it. And there we go. Look, you see, it found it and it replaced it. So you can do find and replace in a string as well. Okay. I guess I showed you this command several times, num to str, str to num, but I re-emphasize it. So when I have a number like 2, it's just a floating or double precision. But if I say a num to str of 2, the result is character 2. Okay? If I say that number 2 plus 5, the result is 7. If I say this conversion of that to string plus 5, the result is 55. Seriously? I added 2 to 5, that's 7. Good. But why is it that when I convert 2 to string and I add 5 to it, the result is 55? So it tells me this string version of number 2 should be 50. And is it? Yes. If I go back and look at the ASCII table again, you see that corresponding to number 50 is what? The character 2. Okay, so what you're doing here is you are doing the typecasting and add 5 to that and then convert it back to the equivalent ASCII value. Okay, but this number 2, when it's converted to string, I can concatenate it with the rest of the string. So let's say I do something like this. I have been working with MATLAB for, and then 20, and then years. Can I combine them like this? No. You see, it didn't give me an error, but it did give me some kind of crap, right? I expected it to say but it cannot, because these are characters and this is just number 20. So it cannot do the concatenation that way. But if you convert this 20 to equivalent character 20 by saying number to a string of that, now you should not have problem. Look. Yes. And if you want the spaces, just add the spaces here and here. Now, I haven't been working really myself 20 years, but I have been working with MATLAB for about 17 years. So let me make it about myself, 17. Yeah, I have been using this software for 17 years and I really love it. So here I'm converting the string into number. Also, if I have some string like 18, as I told you, if I add 2 to it, the result is not going to be 20. It's going to be something like that, which is quite interesting, isn't it? 51 and 58. Why? Well, because 1 is 49. When you add 2 to it, is 51. 8 is 56. When you add 2 to it, that's 58. So here is like adding a number to a character, to an array. This is like adding a number to an array, and this array has 2 numbers in it, 49 and 56. So if I want to do that, I have to say string to number, convert this string to number, and then add 2 to it. Now you get your correct result. Okay, so these 2 commands, str to number, number to str, typecasting, are quite interesting. What else? I can also convert a matrix into string by mat to str, okay, if I want to. I can even convert strings into symbolic variables. Seriously? Yes. So for example, let's say I say sims of x, and then I say f equals sine of x, or 1 plus x squared, whatever. You see, this 1 plus x squared is actually a string. It's not a function of x right now. I cannot take derivative from that, for example, right? I cannot say diff of f and 1. You might say, what is this doing? What is that? Well, here, again, it is treating this like a vector of numbers. Whereas the numbers coming from, they come from the ASCII. So that is 49 plus is some number, x is some number, caret is some number, 2 is some number. So this is an array of 5 numbers. So when I say diff, what does it do? If you remember in vectors, I mentioned it. It is subtracting each number from the previous number and keep going. So out of 5 numbers in that array, you get a 4 by 1 like this. So basically, the first one is plus minus 1. They're equivalent ASCII numbers. The second one is equivalent of x minus equivalent of plus, equivalent of caret minus equivalent of x, equivalent of 2 minus equivalent of caret. Okay, but it does not make any sense. If I expected to get 2x, I'm not going to get it. But can I convert this string into symbolic? Yes. There is the command that convert your characters into sim. Okay, let me see if we have that. Still, it should char to sim, or str to sim, I guess, of f. There we go. Now this answer, if you look at it, it is symbolic. Now if I want, I can take the derivative of the answer. Okay, so there is this command also for going from characters to symbolic variables called str to sim. Okay, so I'm showing you all of these typecastings. One more thing is eval, and then finally sprintf, and then I'm done. Eval. So if I say 4 times pi, but in a character like this, nothing happens. Because this will, in here, there will be no calculations, right? It's inside quotation marks, so MATLAB just look at it and not do anything. It just takes it literally without any calculations. But what if I really want to evaluate this term 4 times pi, although it's a string? Can I evaluate it? Yes, I have to use the command eval, which is used for evaluation, even though it's a string. Here we go. That's 4 times y. Okay, so these commands are all useful. It is also used to evaluate symbolic expressions, right? We mentioned that in symbolic toolbox. So the command eval is a very powerful command that works also on the strings. The last thing is sprintf. So far we had fprintf, right? Remember we had the command fprintf, and the fprintf will combine numbers, text, and everything into one giant text and show it either on the command window, if you don't provide the name of any file, or if you provide the name of a file, it writes that big string to the file. Now there is a command similar to that, it's called sprintf, and sprintf will only generate the string, but does not write it anywhere. Does not write it to a file, does not write it to the command window or anywhere, just generates it. That's called sprintf. So what's the use of that? Let's say here, you want to create a plot of function sine of w times x, where w is the frequency, and you want to keep changing this frequency and updating your plot each time with the new frequency, but you also want to update the title of the plot as well. So the first time, say y equals sine of 1x, then y equals sine of 2x, 3x, and so on. So you want to update the string, which is the title of your plot. How can you do that? Well, this is what you do. You say x equals lin space of, let's say, 0 to 2 pi with 100 data points. And w can go from anywhere 1 to whatever you want. Okay, so this is what you do. You say for w equal, let's say, 1 to 5, y equals sine of w times x. Plot x versus y, and then you can have x label and y label, but for the moment, let's just update the title. Title is what? Y equals sine of w times x, where w gets updated when it goes from 1 to 5. So the way you can do it is this. You can create this text string with the command sprintf and say it is y equals sine of %d x and w. You see here, it's very similar to fprintf, but it's not going to write it to workspace or anything. It's just generate a text, store it in this variable txt. And now I say use that for what? For the title. And then do a small pause so that I can see the result. And then, okay, let's see what happens. You see? So I keep updating this text, which is the title of my plot. So this command sprintf can be really useful. Now, not that you cannot do it with concatenation. If you want, you could. If you want, you could. You could simply say something like this. Y equals sine of until here. And then here you say num to string of w, correct? And then x, like that. And then put it as the text. That would do the job as well. You see? So it's up to you, but the command sprintf in these situations can be very useful. Okay, I'm looking at my notes. I think I have covered everything I wanted to cover for strings. So we stop the lecture right here.